Let's discuss vector addition. Vectors can be added if we have a vector A and vector B. We can define a new vector, C equal A plus B, by a geometric construction. Process is quite simple. To add vector B to vector A, shift vector B parallel to itself until its tail is at the head of vector A. The vector sum A plus B is a vector C drawn from the tail of A to the head of B. The order in which the vectors are added does not affect the result. Now, how do we subtract vector B from vector A? This operation is equivalent to adding vector minus B to A. Vector minus B is same as vector B, but it has an opposite direction. Notice that this is vector B and this is vector minus B. Again, we shift vector minus B parallel to itself until its tail is at the head of vector A. The vector A minus B is a vector D, drawn from the tail of A to the head of minus B. Vector addition satisfies the following four properties. Commutativity. The order of adding vectors does not matter. A plus B is just the same as B plus A. Associativity. When adding three vectors, it doesn't matter which two you start with. Identity element for vector addition. There is a unique vector, zero vector, that acts as an identity element for vector addition. Inverse element for vector addition. For every vector A, there is a unique inverse vector, so that when we add vector A with his inverse vector, we will get a zero vector. Let's discuss multiplication of vector by a scalar. Vectors can be multiplied by real numbers. Let A be a vector. Let C be a real positive number. Then the multiplication of A by C is a new vector, CA. Now, if C is greater than 0, then the direction of vector CA is the same as the direction of A. If number C is less than 0, then the direction of vector CA is opposite of A. Here we see that number C is minus 3. Scalar multiplication of vectors satisfies the following properties. Associative law for scalar multiplication. In this case, the order of multiplying numbers doesn't matter. Distributive law for vector addition. Vector addition satisfies distributive law for multiplication by a number. Distributive law for scalar addition. The multiplication operation also satisfies a distributive law for the addition of numbers. Identity element for scalar multiplication. We can see that the number 1 acts as an identity element for multiplication. Let's do an example of adding vectors multiplied with scalars. We have vectors A, B, and C. We want to find vector D, which is A plus 2B minus 3C. First, we draw vector A. At the head of vector A, we add vector 2B, which is two connected B vectors. After that, we draw vector minus C, and then at the head of vector 2B, we add 3 minus C vectors. Resulting vector D is drawn from the tail of A to the head of minus 3c vector.